In this section, we will go through the key aspects of setting up our test environment and understanding the key concepts of the unit test procedure. This is perhaps the most important section of the course, as it ensures a reliable blockchain application. We will start by setting up a basic test environment. Then we will build basic tests for our assets and participants, as well as for our transactions and our queries. In this video, we will set up the test environment. We will be using the Mocha test framework, the Chai assertion library, create a set of fixtures, and a basic test file skeleton. We connect to our virtual machine and navigate to the location of our network. We then run npm install to install the core dependencies. Then we add a few extra dependencies that we will use, namely Dirty Chai and JS YAML. We can run the npm test command even though we have not defined any tests yet. This will lint the files and tell us if there are any problems. We can fix the small issues in the code that ESLint highlighted in the lib/logic.js file, such as adding a semicolon on line 6 and using exact equivalence on line 52. We can now run npm test again. We are missing a folder called Fixtures, used by Cucumber, and at the time of writing, NYC does not integrate with the Mocha tests that we are running on Hyperledger Composer. Hence, we will substitute the test call we make with mocha-t0. Thus, we exclude Istanbul coverage and Cucumber for the purpose of this tutorial. The tests throw an error because we don't have any test files yet. Let us start by creating some fixtures, which will contain example individuals and land titles encoded in YAML. The fixtures contain the definitions of 2 individuals and 2 land titles, which we will use in our tests, so that we don't have to hard-code these directly into the test code. We will also create a very basic test file. This will load the key dependencies for our code. These include the Composer admin connection, the business network connection, the business network definition, a certificate utility, and an ID card helper from the Composer common package. Here we will also load standard modules such as fs for the file system, path to handle paths, and JS YAML to work with our YAML fixtures. Next, we load all the components we need from the Chai assertion library, such as its expect module and a plugin called Dirty Chai, which makes test calls explicit as functions. We then define some constants, such as the namespace we are working in and the peer admin credentials. Finally, we load our fixtures, which we will eventually use. Let's test that the file is correctly processed and throws no errors. We've now set up a basic environment for testing. Since we are using Mocha, we can set up a set of placeholders by using the describe and it functions. We can create a hierarchy by using nested describe calls. This displays the tests we plan to have by the end of this section, ensuring that we can create identities and land titles, submit transactions, and run queries. Let's run npm test again to show how this is all displayed. We start by adding a Mocha before hook, which will connect to the fake blockchain and initialize the network components. Let's look at all the steps we take here in turn. Firstly, we define a set of variables that will be accessible in the before hook, but also downstream in all the tests that we will run. Then we define the actual before hook using the before function. We use the async keyword to enable us to use await statements to get code that is a bit simpler to read than promises and works synchronously. We first specify a card store, which in this case will be held in memory for the purpose of our tests. We also specify a connection profile using an embedded connection, since we don't want to spin up a whole new Hyperledger Fabric cluster each time we do our testing. We use this embedded connection to generate a set of certificates to be used as credentials by the administrator of the test network. Just as we did on the command line, when launching the network for real, we define a peer admin identity, acting as a peer and channel administrator. To do this, we create a new ID card and an admin connection object. Then we use the admin connection object to import the peer admin identity card and connect. We can then create a business network connection and a network definition using the files in the LandReg directory. We then install the Composer runtime for our LandReg business network, again as we did on the command line using the Composer CLI. We then start the business network. We do this by first specifying some start options, including the enrollment name and secret we defined previously. We start the network using our peer admin connection. Having started the network, we can import the network admin identity card and use it to connect to the business network. Finally, we use the business network connection to set up a factory and load our individual and land titled registries, which we will use in the tests to load and store individuals and land titles. In this video, we looked at how to set up our test environment to have a basic test file which loads our fixtures and sets up placeholders to hold our tests. Then we use a mocha-before hook to establish a connection to a test network without needing to create a full-fledged Hyperledger Fabric network.